Yesterday, while developing a Node.js client for a third-party API, I stumbled upon an error that puzzled at least 3 developers. We can simplify the error down to this output. This is the number we are looking for, and this is the number we get. We can see that instead of 47,802, we get 48,000. Exactly the same result I got from the Node.js client I have built, but the developer of that third-party API was not receiving the wrong result in his Insomnia tool, which got me puzzled. So I have written this very simple server in Go to illustrate the problem. We make a call to the endpoint, and let's copy it as a curl request, which will be similar to what we get from the Insomnia tool. We slap it here and we can see that the very large number is the same as the string representation of that number. So in the browser we see the wrong result, in the curl we see the correct result, in the Node.js client we see a wrong result, and the most puzzling thing was that if we look at this request in the developer tools, we can see that in the response we see the correct number, and in the preview we see not the correct number. So the preview corresponds to the one we get in the browser and in the Node.js client. The main issue is that if you haven't seen this thing before, you can end up in a situation by trying to catch very nasty bugs. So why is this happening? So the actual issue was that the third-party API, in my case, was using int64 for representing some of their numbers, like timestamps and things like that. And unfortunately, about half of the numbers int64 can represent cannot be represented in JavaScript number without losing precision. Because JavaScript numbers, they are not actually integers, they are floats. And so JavaScript happened to have something called number max safe integer. So if we output this guy, we get this value. And you see, if I just try to copy this number we want to get, we get the wrong version of that number, because JavaScript number cannot represent this number correctly without losing precision, because it is much bigger than the max safe integer it can represent. So in reality, what you need is big int. But the problem is that the reason why we get the wrong result here in the console, why we get the wrong result here in the browser, and why we get the wrong result in the Node.js client, it's because they all use JSON.parse. And the problem is that they all use JSON.parse. Oh, come on. And the main problem is that they use JSON.parse. We can see here, when we use JSON.parse, we lose this precision because the numbers are converted to the JavaScript number, which cannot represent int64 type, which means that you cannot just use JSON on the response you received from fetch. So the very fast, quick round is to use response.text and parse it using JSON big int package, if of course you don't want to write your own custom JSON parser, and I suspect that you don't want to. We will use JSON.text to get the raw response, and then we use JSON big int package, where we'll specify option store a string true, and then when we parse the result this way, when the big numbers are encountered, we see that the normal numbers are still treated correctly, but the big numbers, they are treated as strings, and then we don't lose any precision. Or we can use another option, use native big int true, that will treat those big numbers as big int, because otherwise JSON big int comes with its own representation of big numbers. Hope that was useful and you're not gonna be caught off guard. Thank you for watching, and until the next time.